Hello friends, today QuickSort. QuickSort is an algorithm of array sorting, and nowadays it's the most popular and the fastest algorithm of sorting an array. QuickSort is divide and conquer algorithm. It means that it picks an element as a pivot and then partitions the array into the subarrays. And then it takes these subarrays and also partitions it until the array becomes sorted and undividable. Let me demonstrate you on this sketch how it works in practice. Let's assume we have an array. Let's assume we have 3, 1, 1, 2, -4, 6, and 0, 4. And we need to apply the QuickSort algorithm to this array to sort it. As I told previously, first of all, we need to select a pivot. Usually, when people implement this algorithm, they select pivot as a first element, as a middle element, or as the last element. Let me show you how this algorithm will work if we select a pivot as a first element. So let's assume we selected this element as a pivot. Then we need to split our array to the subarrays, which are less than a pivot and greater than a pivot. So our divided arrays will be like 1, 1, 2, -4, and 0. This will be our first array, and the last array, the second array will be elements that greater than pivot, like 6, and yeah, and that's it. And we select, let's assume we have this array, we select in this splitted array first element as a pivot, and then divide this array to the subarrays. Here we have 1 and 1, and also here I forgot to add 3, because we also need to not to forget about pivot. And here we have 1 and 1, and the second algorithm will be 2, 3, and yeah, and here we have -4 and 0. We also select a pivot, and we split our arrays to the subarrays until we have sorted orders, until we have array with one element only. And let's just navigate to the IntelliJ IDEA and see how it works in practice using Java. Let's create a class, QuickSort, public static void, and let's create a method, QuickSort. In the incoming param, we need to pass our array and the low and high. A low and high is the low element and high element of the array which we're gonna split. Let's assume we have an unsorted array with the next elements: -1, 4, 0, 2, -4, 8, 12, -5. And we need to sort this array. And right now, let's implement this QuickSort to apply QuickSort to this unsorted array. First of all, we need to select a pivot. Let's just select a pivot as a middle of array. So we need to select low plus high minus low divided by 2. It's the middle index of our array, and the pivot will be like array middle. In this example, we select a pivot as a middle of array. We pass low as 0 and high as length minus 1. 1, 2, 3, 4, 5, 6, 7, 8. It's the length of our array, and 8 minus 1 will be 7. 7 minus 0 divided by 2, it's 3.5. And plus 0, it's 3.5. And if it will be casted to int, it will be 3. So we select third element of our array as a middle. 1, 2, 3, 4. Here's our third element, because the indexing of array becomes from the 0. So 2 will be our pivot in the first iteration. And after we select the pivot, we need to split our array to the subarrays, which are less than a pivot and greater than a pivot. But first of all, we need to specify some validations related to our array. If array length is 0, if it's empty array, we need to stop our execution, because array length is 0. And one more checks: if low greater or equals than high, we also need to stop our array, because it means that it can't be divided anymore. That means that we reached the situation then the low is the same as the high. That means that the array has only one element, it's undividable anymore. Okay, we selected a pivot, and right now let's just split the array using this pivot. We say we need to specify some additional variables, e and j, e as low and j as high. And then we just loop through the array until I less than j. Until I less or equals than j, we need to check while array I less than pivot. It will be our first subarray of the big array. So we in this loop we split elements which are less than a pivot. We increase I, and while array j greater than pivot, it's the subarray with the element greater than pivot. We just decrease the j. And we say if I less equals than j, we need to change the positions of the element in array. Just switch the positions. And for switching the positions, we use temp variable as in previous video related to bubble sort. Our temp will be array I will become array j, and array j will become temp. And we need to increase I and j, decrease. And actually that's it. Right now we need to call this QuickSort until we have undividable elements. So we just say if low less than j, then QuickSort array low and j. And if low, if high greater than I. Then we call quicksort array I and high. And we continue call this quicksort until we have a situation then the low will be greater or the same as high. Okay, let's just try to apply this quicksort algorithm to this array. Quicksort array, and low is 0 and high is array length -1. And let's just try to system out the sorted array. Let's start our application. And here you see we sorted our array. As you can see, we implemented a QuickSort algorithm in Java. It's not simple as bubble sort, for example, in implementation, but this algorithm works faster. And yeah, that's it. Thanks for watching. Don't forget to subscribe to the channel.